Now, in terms of MRI, what we've been able to do is use the structure that we get with MRI and combine it with the electrical current that is given off through the activity of the brain over time in a combined EEG fMRI protocol. But as I mentioned previously, this is still very much in the pilot stage of development. For the time being, what we have is a technique called functional MRI, functional magnetic resonance imaging. And the functional magnetic resonance imaging, or fMRI, is in fact about as good as we can get for combining structure and function in a useful way. Functional MRI measures the blood flow through the brain and is able to detect the responding of the brain to environmental changes over time, allowing us to draw some inferences about where in the brain, what location of the brain is active or more active, relatively more active, during the processing of particular stimulus. So, for example, in the case of walking or talking, we would engage the motor cortex much more actively. Even a very simple motor task like finger tapping, which is a typical method of measuring the integrity of functional MRI protocol, then this would be very easily observable as a specific blood flow relative to other parts of the brain. And so we would be able to say that the function of that area of the brain is specifically involved in finger tapping. So the temporal resolution of functional MRI is not as good as EEG, but it's almost as good as we can do in terms of telling us over time where a particular function is engaging a specific part of the cortex. Okay, now in the case of MRI as a neurological examination, we would use the structure more than the function. So fMRI is increasingly being used to assess different types of neuropathology, but the structural MRI report is still the bread and butter of the neurological examination. And in the case of the diagnostic radiology centers around the world, we have more and more demand for brain imaging because of the incidence of Alzheimer's and other neuropathologies increasing every year. So the technology is quickly evolving. The MRI scanners are becoming stronger and stronger. That is, the resolution of the MRI is improving all the time. And now, in fact, with experimental MRI, including here at the University of Hong Kong, it's possible to look in very exquisite detail at a very, very detailed level of cellular structure in the brain, much, much more refined than what we've been used to. And as the imaging technology improves with greater and greater resolution, what we see is a window into neuropathology at earlier and earlier stages. So the problem with imaging in the neurological exam has always been that we only really see pathology after the pathology has developed. A tumor, a stroke, a head injury. We only really see evidence of changes in the brain post-fact, that is, after the incident has occurred. The pathology has set in. But of course, it's much more useful to be able to use the imaging technology to detect pathology before the consequences of that pathology have set in. A little like cancer too, it's not any different in other parts of medicine. The earlier we can see changes in the structure of the body, including the brain, that are caused by some kind of disease process, then the better we are able to detect the pathology, treat the pathology, and cure the disease before the disease takes hold and mortality is the outcome. So as brain imaging technology becomes better and better, we are able to use the images in a more powerful way for greater and better, more reliable and more valid diagnosis of prospective neuropathology. And here's an example of some of the language that you might see in a report from an imaging center. This is simply a sample. You would see in Hong Kong a report that comes from the University of Hong Kong Diagnostic Imaging Center, Diagnostic Radiology Center. And here we would see some examples of, there's very clear evidence in this particular case of some trouble in the area of the ventricles, which suggests that in this particular example, what we call periventricular white matter changes are consistent with the idea that there would be some kind of disease process taking place. The language in this report is quite complex, but I would encourage you to try to familiarize yourself with some of these terms. You will know them by the end of the course, because in the future when you are practicing, you will find that these sorts of reports will be very common, and the language or vocabulary that is used in the reports will be important to understand for communicating with the multidisciplinary team in your work environment.